Hi there, we were talking about quadratic equations in the previous videos and we saw that for any general quadratic equation of the form ax square plus bx plus c equal to 0, by the quadratic formula we get the roots as x equal to minus b plus minus under root of b square minus 4ac by 2a. It is a possibility that the number inside the square root, that is b square minus 4ac, comes out to be negative. Then what happens? Let's take a look. First of all, this number b square minus 4ac is known as the discriminant or denoted by capital D. This is nothing but b square minus 4ac. Now when we have the equation, this one, we can directly calculate b square minus 4ac and easily tell the nature of roots that this equation would have. Now what do I exactly mean by nature of roots? Let's see. So there are three possibilities for the value that this d can take. The first one being b square minus 4ac or d is less than 0, or b square minus 4ac can be equal to 0, and the third possibility is b square minus 4ac is greater than 0. So in these three different possibilities, there are three different outcomes for the nature of roots that a particular equation ax square plus bx plus c equal to 0 would have. So when the discriminant is less than 0, we say that the equation has imaginary roots. Now the roots are imaginary because within the square root I would have a negative term, and we know that when we have a negative term inside the square root, we denote it by a plus iota b, and that is not a real number or an imaginary number. When b square minus 4ac or the discriminant is greater than 0, we say that the equation, this one, has two real roots, two distinct real roots. And when finally b square minus 4ac equal to 0, we get only one root, one real root, or we can say we get a repeating root. Now let me show you what do these three exactly mean. So in the chapter on polynomials, we know that a quadratic polynomial, something of the form ax square plus bx plus c. So if I have the polynomial y equal to ax square plus bx plus c, then it forms a parabola when plotted on a graph. So when a is positive, I have a parabola which is curved upwards. So this parabola can be in three positions. Either it is above the x-axis, or it cuts the x-axis in two distinct points, and finally it could either be just touching the x-axis and moving up at just one single point. And we know that the roots of this polynomial are found when we equate this polynomial to 0. That means y, the value of y, goes to 0. So when we have two distinct roots, two distinct real roots, this is the condition of the graph. We have two distinct real roots. When we have only one real root, that means the graph just touches the x-axis and moves up. So we have just one real root. And when we say we have an imaginary root, that means this graph, this particular orange graph, does not meet the x-axis anywhere, and there are no real roots or we can say we have imaginary roots. Here d is negative, here d is equal to 0, and here d is greater than 0 or positive. So when I give you a quadratic equation, can you find out whether the roots will be imaginary or whether we'll get only one root or we'll get two distinct real roots? Let's look at an example. Say the equation that has been given to us is 2x square minus 4x plus 3 equal to 0. Now we are supposed to find out the nature of roots for this particular equation. Now the first step always is to find out the discriminant or capital D. That is equal to b square minus 4ac for the equation ax square plus bx plus c equal to 0. Now when you compare this particular equation with the given equation, we can say we see that b is equal to negative 4, a is equal to positive 2, and c is equal to positive 3. So to find out the discriminant, we will have b square or negative 4 whole square minus 4 times a is 2 into c is 3. So the discriminant would be 16 minus 4 into 2 into 3 would be 24 or minus 8. So the value of the discriminant is minus 8. What does that mean? Yes, we will have imaginary roots, and the graph of this particular equation would never touch the x-axis, and we'll never get real roots for this particular equation. So we have imaginary roots or no real roots. Now let's look at another example. We are given an equation 2x square plus kx plus 3 equal to 0. Now here we have to find out the value of k such that we get two real and same roots. Now what do we mean by two real and same roots? That means that the discriminant is 0 or we have just one root or the repeating roots as we said before. So in this case, what would the discriminant be? The discriminant would be minus b square. The discriminant is always b square minus 4ac, and we want the discriminant to be 0 in this case. That simply means that k square minus 4 into 2 into 3 should be equal to 0, or k square minus 24 should be 0, or I can say that k should be equal to root 24 plus or minus. Both are valid. So root 24 is 2 root 6. So if the value of k is plus 2 root 6 or minus 2 root 6, the discriminant would be 0 and we will get two real roots which are repeating or which are same. Similarly, we can work out a lot of other problems and find the roots of these quadratic equations. I hope you enjoyed this chapter on quadratic equations. It's very useful, it's a fun chapter, and it's a chapter which will fetch you a lot of marks because you can never get these questions wrong. Even if you get a wrong answer, there's always a possibility of going back and checking it, because when you put the roots in the equation itself, they should satisfy. Bye.